For the next three problems, 12 through 15, okay, at least for 12 and 13, the directions which I kind of cut off say true or false, is the statement below correct? Explain your reasoning, okay, explain your reasoning using mathematical vocabulary, all right? So you're supposed to explain it true or false regardless if it is true or false. So in number 12, I start off with y to the 7th over 8. Again, this is a rational exponent, and any rational exponent can be written as a radical. Remember, we start with our base, 8, that should be our index number. It is. Then I should have my base of y in here to the exponent of 7. It is true. So this is true, okay, because everything is in its current position. Now 13 is a little bit trickier because in trying to figure out if this is actually true, I should rewrite it and simplify it like we did above in like 1 and 2. So when I have 8 to the power of 2/3, again, it's a rational exponent. I start with my denominator 3. I write that as my index number. So I'm doing the cube root of 8 squared. And we can simplify 8 squared. 8 squared is 64. So we can break down 64. I think of it as 4 times 16. Okay, we can break down 4 to be 2 times 2. We can break down 16 to say 8 times 2. Okay, then we can break down this to say 4 times 2. This 2 comes down, and we can think about this even further. Okay, so I can rewrite this 4. I'm going to kind of bring my work up here. I have the first 2, the 4 breaking into its 2's, and then the final 2's. Now, because we're doing the cube root, okay, I'm looking for groups of 3. There's one group of 3, and 2 groups of 3. So I have 2 groups of 3, 2's. So that means I pull out in front a 2 times a 2. Now there's nothing left over, so there's no radical, and 2 times 2 is 4. So that should have been my answer. When we look back up here, it tells us 8. So that means that this statement is false. And using my reasoning, this is my reasoning down below. Now, when we go to 14, it says 9x equals y, and y is a rational number. So which set of numbers must x belong to make this true, and why? So if I have 9 times some number x, it's supposed to equal y, which is a rational number. Well, one of the rules we learned very, very early in the year is that in order to get a rational number by performing operations, I must have a rational times another rational number. That is the only way to get a solution that is rational. So since that's the case, 9 is definitely a rational number because it's a whole number, and they told us y is rational. They told us y is rational, 9 is rational. That means x has to be a rational number. If we change the solution to say irrational, then x would also have to be irrational. Number 15 is kind of 2 parts. It wants us to simplify, similar to what we did before, but then classify. So we're going to start with the simplifying. 64 to the 1/3. It's a rational exponent. I start with my denominator 3. I rewrite it as a cube root of 64 to the 1st, or just that. We've already done the cube root of 64 above. We said it is 4. So really, this is like saying 4 plus e. Now, we have our calculators. E is an actual button. I'll show you where it is. We're going to start with 4. We're going to add. E is the button right above the divide sign. I have to press second, divide. I get this E. And then I get 6.718281828. It looks like there's a pattern, but it's going on for forever. It's not necessarily repeating all that well. So what we're going to say then, if we're going to classify our solution, we're going to say that solution is an irrational solution. Because E is irrational, 4 is rational. Rational plus irrational is irrational.